Hi there, this will be a pretty short video where we talk about section 4.5 on quadratic equations. And what we're going to focus on here is how to solve quadratic equations. There are basically two ways we're going to go about this. One will involve factoring and one will involve using technology. So what you want to keep in mind is, generally speaking, when we're dealing with a quadratic, regardless of what method we're going to use, setting one side equal to 0 will be really handy for us. And a bit of vocabulary is going to use this word 0 as a noun, meaning something mathematical besides just the number. So if x is a value which makes f of x equals to 0, we say that x is a 0. Not the number 0, but a 0 of the function f. So for example, 2 is a 0 of this function, because we could check that g of 2 would be 2 squared plus 2 minus 6, which is 0. So a 0 is basically just a fancy term for it's something where if you plug it in, you get 0. I won't use this word a ton, but it does creep up every so often, so I want you to know what this means. And a really important property that will be useful here is what's called the zero product rule, or the zero product property. And here's what it says. If a times b is equal to 0, then either a is 0 or b is 0, or maybe even both. This is a property that only 0 has. 10, for example, I can multiply two numbers to get 10 without the guarantee that either one of them was 10 to start with. That works for any number except 0. If I got 0 as the result of multiplication, then one of the things I multiplied must have been 0. So that's why it's super handy to set one side of an equation to 0. It makes factoring easier. So let's do a quick example. Let's solve this equation here by factoring, and you can just watch this. So to factor this one, it might involve a little bit of experimentation. The 3t squared definitely comes from 3t and t. And we need to think about combinations that would give us -4. So if I tried, for example, -4 times 1, my middle term would be 3t minus 4t, which is -t, which doesn't quite work. I want the opposite of that. So here, if we check by FOIL. Oh, sorry, I didn't switch it, did I? If we check this by FOIL, we have 3t squared minus 3t plus 4t minus 4. The middle term there is t, that's what we want. So, you have to tinker around sometimes to find the right factorization. But now, by the zero product rule, if two things multiplied together to give me 0, that means either the first factor was equal to 0, or the second factor was equal to 0. And we can solve these individually to get that t was -4/3 or t equals 1. And this is really powerful. If you were just doing this by guess and check, you might look at this equation, and after looking at it for a while, you might notice that t equals 1 is a solution. But it's highly unlikely that you would just notice that the number -4/3 is a solution. So having one side set equal to 0 and factoring is really helpful. So here's an example for you to try. Hit pause and give this a minute or two to solve it. All right, so I hope you've done that. And you might notice that this is not 0. Factoring really only works when things are set equal to 0. So we could add 12 to each side, and we would have x squared minus 7x plus 12 equals 0. This factors as x minus 3 times x minus 4. So by the zero product rule, either x minus 3 is equal to 0, or x minus 4 is equal to 0. So x is equal to 3, or x is equal to 4. Most of the time, if a quadratic has a solution, it has two solutions. And we could check these. If x equals 3, then x squared minus 7x is 9 minus 21, which is negative 12. If x equals 4, then x squared minus 7x is 16 minus 28, which is also negative 12. So you'll have some practice where you make sure one side is equal to 0 and then you solve by factor. Another technique that I'll just talk about briefly, but it's easiest for you to practice this with your calculator, occurs when factorization is difficult or impossible. The examples we just looked at were cooked up in advance to make sure you could factor them. If you randomly create a quadratic, it's probably not factorable. So for those, we want to use a graph. And as before, we probably want to set something equal to 0. And we want to know, where is y equal to 0 on the graph? And if you think about graphs, thinking about where y is equal to 0 is basically like thinking about an x-intercept. So we're going to graph something, and figuring out when a value is equal to 0 is basically the same as finding an x-intercept. And if you do this on your calculator, that's something that can be done automatically. It's in the same Analyze menu where you saw intersections, but it's called 0. It's finding a 0 or finding an x-intercept. In order to keep this all in one video, I'm not going to switch to the calculator. I'll probably do an example of this in class and you can practice. But I will show you something similar on Desmos. So here's an example to watch. We have a frog that's making a leap, and its arc is modeled by this parabola. Right? Generally speaking, if we're dealing with a real-world situation, there's no guarantee that the numbers work out nicely. Out there in reality, not everything is a whole number, not everything is evenly divisible, not everything is factorable. Right? This is the graph we're given. What is the horizontal distance of the leap? So what I've done is I've graphed this on Desmos. So I have this, here we go. So I already put in that equation, and we can see we have a parabola, and if I change my window enough, I can see, all right, presumably this only makes sense for positive y, but we see this arc where the frog is basically starting at the origin, moves to the right, goes up and down. So what we want to know is, where is that x-intercept that's around 20-ish? On your calculator, you can find it more precisely. On Desmos, it will actually find it automatically. So Desmos has found that that's at 20.345. That's where the frog lands. So we had this graph that looks like so. The frog is starting at 0 and ending at 20.345. So I think the units here should have been inches. I didn't mention that. That's the horizontal distance traveled by the frog. Desmos can find an x-intercept automatically. Your calculator can do it, again, if you just go to the Analyze menu. So you'll have opportunities to practice that, but that's the end of this video.